And what are these blue color lines? They are the lines of force. No. So let me bring a dipole. So a dipole, I'll keep it. Tell me what happens. So how the dipole is such that it will be along the lines of force. Now what about the net force on it? Dipole in the field of point charge. Carry on. Now, there's a dipole one. Just tell me like the dipole one. What about the force on it? Zero, non-zero? Should be non-zero. F1 is non-zero. What about torque? It will be zero. A stable, unstable equilibrium. Non-stable, not unstable, no? Because what is the basic necessity condition? Because the field is not uniform. The field strength at the location of negative charge will be more, no? And the field strength at the location of positive charge will be less. So the net force on the dipole will be towards point charge. If you leave it, what happened to dipole? Will it be in equilibrium? No, it will start accelerating towards point charge. So no question of equilibrium. But what about the torque? Torque will be zero. Am I right? No. Similarly, what happened? A student places a dipole like this. Actually, you are supposed to learn. I don't know. You don't learn. That's why I'm bringing. A student has to imagine. Now take this dipole and keep it in the field of various charge bodies you have studied. What are charge bodies? Point charge, line charge, ring, electric field due to disk, due to sheet. Different types of fields are there. There you are going to keep the dipole. What about this second dipole? I kept in the field of this one. So this positive charge will experience force in this direction, F plus, F negative like this. What about the net force? Zero, non-zero. I want, anybody wants to answer, please? So if you find very difficult, at least, like I say, don't look at least you are supposed to draw a diagram of this kind.
Non-zero.
The force should be non-zero, no? So component of F bar will be vertically up, component of F minus also vertically up. So what about the force on the this one? That force will be non-zero and the torque also non-zero. Got the idea? So there's a one way of orientation. I'll keep another dipole of like this. What about F bar? F bar will be something like this. F minus is something of. What about torque? This one. Both are non-zero. This is a third dipole. Got it? Huh? This one. So if a dipole kept in a field of a point charge, then net force will be non-zero, net torque will be zero. Both force and torque will be zero, or force will be non-zero, torque will be zero, or both will be non-zero. What are the possibilities you can put it? Force will be non-zero, torque can be zero or non-zero. But force, can it be zero? Any possibility? Anybody? Can you keep such a way that where force zero, torque non-zero? Is it possible? Any orientation of the dipole in any way so that force zero, torque non-zero? Any orientation, the point charge is kept in such a way that the net force should be zero. Not possible, no? Not possible. Okay, then afterwards we'll go for line charge. The field produced by the line charge. Line charge. Yeah. This is a long line charge. Now first dipole, I'll keep it in this way. Another dipole, the orientation of dipole will be like this. The another dipole. And you should know one more idea of the line charge. If there's a line charge, how the field, if you view from the top view, the field produced by the line charge will be similar to point charge, no? This is the top view. Fine, this one. Okay, now bring it. What about on the first one? There's a second, third. Same condition, F1 non-zero, torque will be 0 here. Okay, but to understand, so you must have a background. So you're going to keep a dipole in such a field. And we know E bar proportional to 1 by R. Here E bar proportional to 1 by R square. And it'll be radially outward. Now, nearby ring, let me bring. Let's see what conditions I'll get it. Now, there's a point where the field will be maximum, no? So I'll keep one dipole here. There's a dipole 1. Then another dipole exactly at a point where the field will be maximum. So what is this? This is a point R by root 2. Check it now. So there's a dipole 2. There's a dipole 1. Torque will be 0. Torque will be 0. Force will be non-zero. What about here? Force will be non-zero. Torque will be non-zero. So F1 non-zero. Torque will be 0. F2 non-zero. Torque is 0. But we know the field is something like a varying, no? So is it possible symmetry about R by root 2? I think I made things very clear. Will the field will be symmetric about R by 2 on the axis? No, not symmetric. So therefore, just at a distance less than R by root 2, greater than R by 2, the field will not be of same magnitude. Of course, it will be directed towards right, but will not be of same magnitude. So therefore, the net force, in fact, will be non-zero about this point. No, so I can bring a situation like this. If a dipole kept in this way, possible, no? It's a simple idea that the force will be somewhere like this. The force will be somewhere here. The net force, net torque will be 0 on these cases also. Of course, we can't exactly tell the magnitude of field, but roughly we can estimate the field here will be of in this direction and the field here will be in this direction. Okay, now the dipole kept in the field of different charged objects. Now, dipole present in the field of uniform charge sheet. I think there's nothing but similar to this one only, no? Uniform electric field already we have studied. So these are all some related topics. I think the plenty of topics I covered. So today you can practice. Singage book, what happened directly, you can take help of that. No, plenty of good numericals are there. Or Singage Galaxy or Balaji publications. These are the books which I do prefer for students for preparation. So take help of them. I'll wind up the class. Okay, we'll same thing. I'll just stop the recording and we'll continue for the counseling. What all doubts? Who all having doubts? You come. Send me the question. I'll explain on the Zoom. Who are not having doubts, you can carry on the preparation. You can log out of the meeting if